Hello everyone and welcome. Thank you for joining our technology panel discussion on this lovely morning in Munich, and how great is it to be back at Intersolar. So firstly, my name is Tim Day and I'm the investment fund manager for Trina Solar, and today I'm joined by Sebastian from Fraunhofer Institute, Patrick from Mainstream Renewables, Christian from Power Electronics, and lastly but not least, my good friend Adele, who is head of product solutions and marketing at Trina Solar. Before we begin, if you have any questions, please head to our LinkedIn, YouTube or Facebook channels and leave your questions in the comment section. The team will answer all of your questions during our live Q&A at 4 p.m. today. So maybe I could just ask the panel to give us a quick introduction. Patrick, perhaps you'd like to go first.
Thanks, Tim. My name is Patrick Warren. I'm Chief Technical Officer at Mainstream. Mainstream is a large-scale wind, solar and hybrid project developer and asset owner.
Thanks, Patrick. And Sebastian?
Hello, everyone. My name is Sebastian Nold. I'm heading the team of Techno-Economic and Ecological Analyses at the Fraunhofer Institute of Solar Energy Systems. And we are providing research for the industry along the whole PV value chain, especially photovoltaics, but also other industries. Brilliant.
Thank you, Sebastian. And Christian, perhaps you next.
Sure. My name is Christian. I'm the Product and Application Director in Power Electronics. In our department, we mainly provide pre-sale support to quotation and the sales team. And in Power Electronics, we are mainly one of the leaders of central inverters.
Brilliant. And Adele?
I am Adele. I'm head of product solution and marketing for Trina Solar Europe. As you know, maybe Trina Solar is a leading supplier for module, tracker, and also we're heading as a solar energy provider in the industry.
Brilliant. Thanks, Adele. Okay, so thanks, everyone. So first of all, let's talk from the perspective of an investor and asset owner. We've seen strong growth in the solar industry within Europe despite the pandemic. From my point of view, solar is attracting new investment companies and new players into the market thanks to its high returns and low risks, while I also see existing investment partners increasing their portfolios and building strong pipelines. So one of the interesting aspects of the industry is the rapid technology evolution. So a question first for Patrick and Sebastian. Investors and developers plan their projects and pipelines 2 to 3 years in advance. So what technologies do you look at now to help make the best choices and the best asset for the future? From an investment point of view, what can we do to speed up the uptake and bankability of new technology? And maybe Patrick, do you want to take that one first?
Yeah, sure, Tim. I think there's a huge amount going on at the moment across the full industry, whether that's modules, inverters, trackers, storage or beyond. But maybe starting with the module, I think the technology that we'll see in the coming years is very much going to be towards N-type, and that transition from mono PERC to P-type to N-type. I think that's, a big wave of the future, and we think that's definitely going to be implemented in our projects in the next 2 to 3 years. Large format modules, I think, is another technology that we saw last year and this year, and we expect that trend to continue. Difficult to look beyond that around perovskites. Maybe that's on the 5-year horizon rather than the 2 to 3 year that you're asking about. I think beyond the module, then we'll see smarter trackers, smarter algorithms, maximizing yield, and we'll probably see, the maturing of trackers that suit large format modules. We certainly expect all major tracker suppliers to have that sort of technology on the market soon. In terms of inverters, then I think the main question for us that we've been asking ourselves recently is central versus string inverters. We continue to model that on a project by project basis and pick what's best for the offtake agreement that we have or for the resource that we have on the site. And then of course, storage, we're planning for storage across almost all of our projects, whether that's integrated with the inverter or a separate piece of kit. We're planning for both. So I think that's what we're looking at in the next 2 to 3 year period, Tim.
That's brilliant. Thank you, Patrick. Really interesting, actually, and it mirrors some of our thoughts, I think. So really appreciate that. Sebastian, any thoughts from yourself?
Yes, of course. I fully agree with what Christian said, that we on one side, we will be from the technology side, we'll be seeing larger modules, which we already see in the market, but different cell technologies. So N-type, he already mentioned, will be coming up. So some manufacturers start producing TOPCon cells, heterojunction cells, having a new revival. Other companies are working on tandem cells, with perovskites, single junction, dual junction cells. So, and we also might see further shingling technologies also seeing the market. So different module types, different module sizes, as we already see it. So I think we see a larger diversity on the module side. I also agree that we see that in almost every system, their storage must be thought with it. But beyond technology, there's important things I would also mention. So behind the drive of in the last years, more than quality and efficiency and higher energy yield, we see a larger, I think, diversification in the whole market. So PV will be everywhere. So in the future, so we will be looking in further solutions. So building integrated photovoltaics, also around you in an urban environment and parking lots and roads, but also vehicle integrated. And I think we also think a strong industry might be also the agricultural industry to merge in agricultural areas with photovoltaics called agri-photovoltaics. So to sum it up, there will be new system types, new solutions coming up in the future to integrate photovoltaics further in the society. And additional to that, I see it will be very important for the industry and for the companies to think greener in the whole manufacturing value chain, yeah, from the suppliers onwards through the whole chain until the end customer. Customers are more looking at lower CO2 footprint, but also CO2 footprint products, yeah, less usage of critical resource. So the products should be designed also in the future for circularity. And we already see companies looking into this, already promoting the that they're using less resources and less energy for producing their products. And this is important for then corporate sustainability reporting, and also I think to attract finance for their company. And the third point I want to mention, I think that we see on a global wide more decentralization of production as we have it now. So more and more countries are starting up new factories and producing solar cells and modules. And so, and this is also then a local drive, so establishment of local manufacturing value chains, and which will also be industry, especially for the European market, to use products coming out of Europe for the projects.
That's really interesting, Sebastian. Thank you. Okay, so let's look at the main components of a solar system, and I'm keeping it simple. So I'm thinking modules, inverters, mounting structure. We've seen some major changes and improvements in these components. As an example, we see much larger wafer sizes and much higher power modules. I mean, if you look at Trina's Vertex 210 series, giving you up to 670 watts from a module. So perhaps Adele, Christian, and Sebastian, you can talk about your experience in these key components and maybe touch on what we can expect in the coming years. So Sebastian, perhaps you could cover your new research that you've been doing. Christian, obviously talk about inverters, and Adele, if you could cover modules and structure. And maybe let's just go straight back to it, Sebastian, to kick that off.
Yeah, so thank you. Yeah, so as the whole market in the last years was really focusing on the transition to PERC, now almost the full market is using PERC solar cells and P-type material. And we now see that here this is coming to an efficiency limit. Yeah, so there's still headroom for PERC going towards passivated contact solar cells, but there's also other streams in the market looking into the upgrade of PERC. So one could be passivating the full back area contact towards the and using N-type wafers for using TOPCon solar cells to have an additional efficiency headroom on the cell side. Others are looking into starting up manufacturing silicon heterojunction solar cells, which also have the highest efficiency potential, and as the world record cell, it's also based on a heterojunction. Another trend is to produce or to go towards tandem solar cells with perovskites on top. So here this is of course a strong topic currently also in research, and there are first companies trying to industrialize perovskite tandem solar cells. So they are now, we see a diversification in the cell side, and they have to prove, of course, durability in the market, but there's on one side small changes. I would say if you go towards TOPCon, or there's a heterojunction cell, of course, proven technology, has been a long time in the market. There are the newcomers, these tandem cell types, perovskites coming, and there's a lot of research going on also towards reliability and durability. And we see solutions out there that these are viable products for the industry to even go towards higher efficiency and higher energy yield on the same area, and reducing levelized cost of electricity, the cost of energy production on this side. On the system side, we also see that higher performance ratio and also bifacial systems are increasing also in the market. Also through lower temperature coefficients, but also to more efficient and optimized system design. And we see, of course, with these new technologies coming up, it's very important that you have testing of the new products in independent tested beyond the common standards, that this attracts, of course, investors to go with these new technologies coming up in the market.
So bankability, yeah. Thank you, Sebastian.
Yes.
That's great. Christian, do you want to touch on some stuff
Sure.
around inverters?
Sure. I would say on the technical side that, as we have been discussing, new panels are arriving into the market, offering at the end higher power. The main purpose of that at the end is reducing the LCOE. I think one of the main changes that we are seeing in the PV projects with this panel is the length of the string, actually. Of course, the design depends on the location of the plant, but generally speaking, we are seeing a lot of plants where the engineers are pushing the DC voltage up to values higher than 1300 volts. When 2 or 3 years ago, this value were never higher than 1100. So we are seeing this trend, like the DC voltage is being increasing. At the end, this is resulting in several benefits for the LCOE: reduction of the DC cables, reduction of the number of trackers, reduction of the string boxes, and last but not less important, this allows the inverter, the central inverter, to work at higher voltage, AC voltage, and optimizing at the end even more the capex, because they are providing more power. Regarding future, I think what we can expect in the coming years, it will be more related with the software part of the inverters. We are seeing more demanding grid functionalities for static converters, the one used for solar, batteries, and even wind. And the reason for that is mainly the growing penetration of renewable energy in the electrical grid. One of the most complicated challenges of a 100% renewable grid is how to replace the inertial stability provided by the spinning generator of the current electrical system. But at the end, not everything is lost. Don't worry. We, the manufacturers, we are working on emulating this behavior, this inertial stability, and it's something that we have been working on in the last years. This is usually called virtual synchronous machine or virtual synchronous generator. And this control mode will allow the inverter to deliver power as a voltage and frequency source, even when there are faults in the electrical system. So I think this will be very, very important in the near future. So as a conclusion, I would say the higher renewable energy penetration will require new and more sophisticated control functionalities to allow the grid operator to run the new electrical system, this new paradigm.
Brilliant, Christian, thank you. And it's clear I have a lot to learn about inverters, so thank you for sharing that. Adele, perhaps you want to just talk about modules and maybe touch on frame as well.
Yeah, actually, Patrick and Sebastian already mentioned a lot about the module side. I think they're really experts on this. But based on what we see, especially with our global customer, what they want, we see mainly three trends. The first one is continue to the growing in the power for the module. I remember when I joined Trina 12 years ago. At that time, the maximum power per module was like 190, 200 watt. That was it. And then today we already launched 670 watts. It's really impressive. Also, Sebastian mentioned the PERC technology, right? And Patrick, it's already the main technology for the industry today. And 12 years ago was poly and maybe small mono wafer modules. So the module really grew from 125 millimeter wafer to 156, 158, 166, eventually 182 and 210. So you see it's continued to grow because the technology for the ingot puller continue to improve. So today we can build bigger ingot, and also, for example, the glass can be wider today. So the whole value chain basically upgraded to cope with a bigger, more robust high power module. And this is where we're heading as an industry. So not just Trina ourselves, and also many partners choose 210 technology as a base platform for module moving forward. So it's a really great news for the industry. We have a very standardized wafer, cell, and module size, and moving forward. And then we going on bifacial and N-type, right? But we have a very standardized base, and which is already happening at the moment. Actually, 1.5 years ago, the industry already kicked off to standardize on the module side. So this is the first trend, the standardization of cell, wafer, and module at the 210. A second trend, the same as they mentioned, is a bifacial. So surprisingly, actually, I actually saw the number. So this year, globally, market over 80–90% of actually a lot of utility projects, they already use bifacial. Very surprised, right? In Europe, because we have many low irradiance region, also, they actually use a lot of bifacial. So in utility scale project in Europe this year, already over 50% project are using bifacial. We will see that will continue to grow. So this is the second trend. And the third trend is definitely the N-type. As we know, N-type has the wafer module has many advantages. For example, it also has better bifaciality, better temperature coefficient. So actually, it's really a perfect combination with the second trend, which is the bifacial. So we do believe N-type will be the next big thing for the industry. And it already started. So Trina actually already shipped like over gigawatt N-type. It was TopCon. And moving forward, we're also in our R&D pipeline, we also have many different technology. Actually, Sebastian already mentioned them all. So of course, the biggest challenge for the industry is when the cost of these new technology can reach an optimal level, so we can bring the best value to our customer and to everyone, right, for solar energy to make it more competitive. So these are the three trends we see on the module side. And for the mounting structure side, actually, we have many type of mounting structure. We have on roof, right, floating, also agriculture, utility. I will give a more example about the tracker, right? So tracker is a bit similar what Christian mentioned, actually, also the software, hardware. So for the hardware side, it's very important, of course, because the modules are getting bigger and more powerful. So the tracker has to be very compatible with these bigger modules, so they can handle these big modules in the site for 25 to 30 years. So this is essential. And also it should allow our installer to do the faster installation, and also for our customer to have low maintenance, right? Because they move, but still they have to have very good quality. And on the software side, the tracker has to be very smart, exactly same as inverter. So we cannot treat tracker as a hardware. It's actually a piece of software as well. And it's very important we have a very intelligent tracker. I think mainly two benefits. The first one is to have more power gain on the backside, especially for the bifacial system, because as mentioned, it's a trend for the industry. We'll go to bifacial. So you need an algorithm basically to maximize the front side and back side performance together. So the tracker actually rotates in bifacial system differently to a monofacial system. So this is number one. The second one is the tracker has to cope with very extreme weather. So this year, sadly, we really see a lot of very extreme weather condition globally, and it will continue probably, but of course it's our joint effort to stop it, but still we will face it. A solar power plant will stand in the field over 30 years, even some customers want to have them for 40 years. You will have some storms. So the tracker have to be very smart, right? So we give the data, of course, to it, and it can really protect the solar assets, right? It can rotate to a very safe position to protect over these extreme weather. So this is the main trend we see for the module and tracker.
Brilliant. Adele, thank you. That's really interesting. And actually, you mentioned just then the next subject that I wanted to talk about, which was system integration. Investors, and in fact, all of solar businesses expect the system to be up and running for that 25 to 30-year lifetime. I think you even said 40 years. That'd be great. With all the components working together for so long, the right choice of components and their integration is really vital. So maybe Patrick, Christian, and Adele, just tell us how the owners achieve the lowest levelized cost of energy with the best performance. And Patrick, do you want to take that one first?
Yeah, sure. And 100% agree, system integration is key to achieving a low LCOE. But looking at the levelized cost of energy, I suppose there's four main inputs. There's CapEx, OpEx, there's energy yield, and then there's asset life. And I think I'll hold Adele to that 40-year number in the future, maybe. But we are seeing definitely on the asset life, we're seeing a push towards 35 years plus, definitely in a lot of markets, and that's key to getting down to a low levelized cost of energy, as is, of course, boosting the energy output itself. So, yeah, but I think system integration, Tim, as you said, and collaboration between partners is 100% required to get down to those low costs of energy that we see winning auctions globally. Our approach is to ensure that the technology is compatible, make sure that the PV module fits the inverter, fits the tracker, and the whole system is talking to each other. And as Adele said, not just on the hardware side, but on the software side as well, to make sure that you're optimizing the O&M cost as well to minimize the LCOE. So that sort of collaboration and as early as possible in the process, talking about the design phase of the project prior to financial close, or even getting early engagement with suppliers in the development phase is key. One thing I would say is that the industry is quite good at this on the solar side. If you look at when the PV module suppliers came out with the first large format modules, there was a bit of a scramble. Were the inverter suppliers ready? Were the tracker suppliers ready? Could they handle it? Very quickly, those issues were ironed out. So I think, as an industry, we're very good at ensuring that collaboration occurs between the suppliers and developers, and again, with the third-party testing and certification bodies, they're part of the process as well. So all those things are key to keeping down LCOE. Keeping down cost of capital is another thing I'd like to mention. Bankability, Tim, you mentioned earlier, but it's fine having all these new technologies and saying your energy yield is excellent with this system design, but you have to get the lenders on board and get them comfortable. Otherwise, your cost of capital is going to be high and your LCOE is going to be affected. So third-party testing, track record of suppliers, not just the company, the technology that they're using, all those things are key to getting down towards those very low cost of energies.
Thanks, Patrick. That makes perfect sense. And I mean, the investment partners that I work with would echo everything that you just said there. So really interesting. Thank you. Christian, perhaps you want to add some thoughts to that?
Sure. Well, first, I would say that using high quality product is a key factor at the end. Sometimes we are paying too much attention to the CapEx and forgetting about OpEx, and that could result in problems in the medium and long term. And on the other hand, and I think this is more interesting, we are seeing mainly power electronics is seeing in the US how integrating energy storage into PV plant is helping to reduce the LCOE by using at the end DC coupling system. This technology allows to recapture the clipping losses. I mean, the losses when the power available in the PV field is higher than the maximum power of the inverter. Injecting this grid into the battery system and discharging the battery when the cost of the energy is higher increases the incomes of the plant, and at the end improves the LCOE. And same thing can happen when the grid operator is curtailing the plant. Again, this is usually happening a lot because high-end renewable energy penetration. So even when the inverter is offline, because maintenance batteries can be charging using the energy from the PV side. So there are many advantages with this kind of technology that we are seeing in a different market. I would say that adding storage to solar gives the system operator the ability to bid firm capacity into the energy market. Imagine your storage system is fully charged, entering the next 24-hour period. The system owner can confidently bid into the day ahead with no concern about weather conditions. But of course, before seeing this, we need new regulation, we need policies, and we need the countries to encourage this adoption that is a bit different than the AC coupling system that we are seeing more here in Europe.
Brilliant, Christian. Yeah, that's very true, and thank you. And Adele, do you want to add your last thoughts?
Yeah, I really agree what Patrick and Christian said. How I see this topic is I see there are two levels, because almost on daily basis I got requests from our customer about compatibility between different components, which I think is a very basic minimum we should do. I mean, among different components, so it's compatibility. The next stage is full integration among different components. What does that mean? We have to work together, right? Patrick mentioned we're as an industry, we're really doing great. We're growing so quickly. I think it's also thanks to the very strong collaboration among different parties in the industry. And then we should really do more co-engineering together to make sure all the components can work well together. I think this is really why, for example, this time the ultra high power module can be used and adopted by the main players so quickly, because we work very closely together. This is essential for a successful industry. So what we have done on the integration side for different components, right? I would give you again the example on the hardware and the software. On the hardware side, I would see there are two parts. One is a mechanical side integration. Mainly it's the module and the mounting structure. It's very important. Again, the module are getting bigger, more powerful. How do the structure and handle, and the customer can benefit from this innovation, right? So on the tracker side, for example, many of the leading tracker brands, we working together to extend their tracker lengths and to cope, and also with the bigger module, and also to have more modules per tracker, so they can allow customer to save on many costs, for example, civil work costs, installation costs. So this is very important. So they improve the tracker and module side, improve design together. Another thing is on the reliability, right? On the mechanical side, because module and tracker, can they work very well together, right? During its lifetime of the solar asset. So in our case, for Trina tracker, we have done a series of wind tunnel tests, right? Which is relatively new for the industry, but it's very, very essential, because as you can imagine, tracker moves, so module moves on the tracker. So it's very dynamic. You cannot use the old method, just static test load. You have to really simulate the real case. And especially we have very extreme weather today. So all these tracker and the big module actually went through the wind tunnel test, and we optimize our design again to calculate the steel usage for the tracker to make sure the customer can enjoy the lowest cost possible, but also have a very robust, reliable system. So this is on the mechanical side. On the electrical side, it's very related to an inverter. Christian actually already mentioned. So for the 210 module, actually has a very unique design, because if you remember, the industry actually in the US, for example, it was 600 volt DC, right, system for rooftop. And then we expand to 1,000 volt. Europe was always 1,000 volt, right, globally as well. And then we evolved to 1,500 volt. But why we did that is because we can extend the string length, and then we can save on the BOS cost. But at this point, because 1,500 volt is a maximum for the medium voltage, right? If you go over, it's a different. So, and now we think, okay, what can we do to further extend the string length? We actually work with customer together, and we got inspired by them. So for the 210 module, we on purpose lower the voltage per module. So in the 1,500 string, you can have more modules and also more power per string and onto the bigger tracker. So that's how we lower the CapEx. But again, we don't sacrifice the reliability, right? Because we went through a lot of tests. So that's the integration we have done on the electrical side to maximize the string power in the system, right, for the 1,500 volt. And then for the software side, it's also essential in the integration. Again, we'll give you an example more on the tracker side, because a tracker, again, it has to be a very intelligent piece in the whole solar asset. And also it has to very well integrated into the SCADA system of our customer who, whichever system they design or choose. So we have to give the data, right, to our customers so they can do a lot of preventive maintenance in the future to minimize the cost. So I think these are the contribution we can do on the module and structure side to help the assets owner to lower the energy cost.
Brilliant, Adele. Thank you. That's really helpful, and thank you to all of the panel for sharing your experience and insights. It's very much appreciated. So I'm going to challenge you now, panelists. Can you give me a 10-second or a 2-3 point summary of your thoughts from today's panel? So Sebastian, I'm putting you on the spot first. Would you mind having a go?
So thank you. Yeah, I think we will see a more diversification in the market of technology, but also in applications. So new applications like building facade integration or agricultural are coming up. Another important point is greener manufacturing towards a circularity economy, yeah, and as well as transparency along the PV value chain I think is crucial for the companies. And the third point I want to mention is decentralization of production globally. So PV value chains will be getting more global, more localized production in different countries. So I think these are the trends for the upcoming years from our side. Yeah.
Excellent, Sebastian. Thank you. Patrick, how about you?
Yeah, I think our industry the last few years has been obsessed with, lowering the CapEx, the dollars per watt of a module. And I think my main takeaway from today is that the technology advancement is wider than just the module, and all the things that Adele mentioned about increasing kilowatts per string, kilowatts per tracker. It's all with the system integration in mind. And I think that's how we'll lower LCOE in light of the challenges of lowering pure module CapEx driven by, commodity prices or shipping prices. I think there's a much wider pool there of levers to pull to lower the LCOE. And I'm kind of encouraged by what I've heard today and what we've discussed on the panel, that there's technology across the full design of a PV plant that will get us there and get us continuing the lowering of LCOE in the years to come.
Brilliant, thank you, Patrick. And Christian, how about yourself?
Yeah, I will give you just a couple of points. First one, sooner than later, I think we will see a lot of solar plus storage integration in plants. And the second one, I think we will be seeing more advanced and sophisticated capabilities for central inverters to interact in the new grid model.
Makes sense. Thank you. Adele, how about yourself?
I think what I learned from today is everyone is very positive about our industry. I can see the passion. We're really amazing industry. We all work together to build. So it's really incredible. And I think from our side and also many partners along the value chain, we should continue to work very closely together to make sure we're very compatible, we are very integrated. It's module, it's tracker, another mounting system like floating, right? Inverter, storage. We have to really work very closely together to make sure we have a very healthy industry going forward. So to make solar more competitive in the whole energy world, I think this is really exciting. I'm very proud actually to be the industry to working with everyone together.
Brilliant, Adele. I absolutely mirror your thoughts from my point of view, and I'm biased, but long-term strategic partnerships are the way forward, because that will bring the technology through, and working strategically, we're much stronger together. So yeah, absolutely right, and thank you. Sadly, we're out of time. So firstly, I want to thank the panel for taking part in our discussion today, and to remind you that if you have any questions, please jump over to our social media channels on LinkedIn, YouTube and Facebook, and leave any questions you have in the comment section. We could be doing a live Q&A session from our booth at 4 p.m. today. So for now, thanks again to our panel, and I hope everyone enjoys Into Solar. Have a fantastic day.